and we'll explain that blockchain should not be called blockchain anymore, but rather time chain, and why. That's an interesting topic, and we'll have some discussion. Then we'll have Tom Weiss telling us some insights about like Bitcoin trading, because he's also Bitcoin maximalist. And I actually encourage people who came here from abroad, like Thomas. We have very interesting like crowd, like Thomas. Thomas so he's the founder of Electrum Wallet. Electrum Wallet is like the most ancient wallet in the West in Bitcoin. We have other people. I encourage to do afterwards like a 3-minute short pitch. Who are you and what you do? Maybe you will find team members or some interesting discussion, become really interesting. So, but first we will give the word to Giacomo. We will take an hour or 2 or 5 or maybe forever to explain why blockchain is not blockchain. Okay?
Thank you, Pavel.
Great. Okay, Giacomo.
Okay. Thank you. So I will stay on this side of the screen because I am on a leash. Tone owns me on a leash, so there is this slavery situation. And so I'm very happy to be here. This is the actual room in which I gave my first public speech in English. People now is sometimes complimenting with me about speeches, but you have to know that 5 years ago, 2015, it was 4 years ago, I didn't speak any English. So my speech here was basically gesticulating and doing some noises and showing some pictures. Now, of course, my pronunciation is just Oxford level. But back then, I mean, it's hard to believe, I know, but back then it was not good at all. And it was at this very room and the first BIP conference. How many people, Pavel? Like 60 people? 60 people. And Lawrence Naum, the creator of Green Address, Nicola Baccao, Ledger, and Felix and some other friends. It was fun. So tonight I will speak about terminology again. The ones of you who were in BIP yesterday have probably watched my speech about the time chain, which was a speech about terminology in Bitcoin. And this speech is all about terminology. This is the longer version, like 5-6 hours, of a shorter talk that I gave in Santiago del Chile. But in Santiago del Chile, they cut me off, so I need to finish it. So now I will finish it, because I think that terminology is actually very important. In Bitcoin, there are a lot of misconceptions. Some misconceptions are in good faith because people just doesn't understand something. Many misconceptions are used in a very fraudulent way in order to scam people, basically. And when you have a misconception about the concept, what you need to do first is to clarify words, because if words are used in a very confused way, you cannot explain concepts without clarifying words first. So what is, can you put like full screen from this?
Mm-hmm.
I think.
1 second. Present.
Okay, great. And now it works. Great. So I have to stay here. So this presentation is about Bitcoin terminology, mistakes, misconception, false trends, ambiguities, and newspeak attacks. So also intentional, misleading misuses of terminologies and words. I think this doesn't work if I'm not in direct full screen. No, I think only when it's selected the full screen.
You are. Try it now.
Yeah, now it works. Okay.
Right.
So this is not about suboptimal but not ambiguous Bitcoin terminology. For example, you know that there were some famous comments by Andreas Antonopoulos that every single term inside Bitcoin is wrong. Like marketing-wise, every single term that we use in Bitcoin is really wrong from a marketing point of view. For example, we use the same word to indicate the Bitcoin, the system, Bitcoin, the protocol, Bitcoin, the network, and Bitcoin, the asset, the scarce asset. For example, in Ethereum, they don't have this problem. They have Ethereum as the system and Ether as the specific asset, which avoids a lot of confusion. Because if you think about that, if you pay somebody with Bitcoin on top of Xapo, you are using Bitcoin, the value determination, the value denomination, but you are not using Bitcoin, the network. And if you are timestamping stuff, you are using Bitcoin, the network, but you are not using Bitcoin, the digital gold asset type. So it's very confusing. Of course, Ethereum made an ICO and raised several millions dollars mostly for marketing. So it's perfectly reasonable that they had marketing right. Bitcoin unfortunately had no ICO, no pre-mine, so people didn't thought about the marketing as well. Wallet also, the term wallet is not very is not very good. Oh, what is going on?
Oh, it should work.
Okay.
There you go.
So I will not speak about some ambiguous terms that I already analyzed in other presentation. For example, maximalism. There is a very long presentation about Bitcoin maximalism. I did first the short version in Riga and then the long version in Ulster in Switzerland. I will not define scam, which is the word that I like more, that I use more, because I already defined it in many presentations. I will not talk about the terminology of monetary units like bits, sats, mic, and stuff like that. I will not talk about terms that are not ambiguous and are only used in ambiguous way by clearly misleading people like Roger Ver or Daniel Kravitz or De Rose. So some terms like Bitcoin, there is people who doesn't understand what Bitcoin is, but it's a very marginal number of people. Most of the people who are honest and not actively trying to mislead people, they don't have any kind of ambiguity about the word Bitcoin. I assume in this room, everybody knows that Bitcoin Cash is not Bitcoin, that, there is no reason to explain that. Probably if you're in that phase of your life, you don't need a speech or a lesson. You just need to stay away from Bitcoin for a few years until you know something better. So I will concentrate on these terms, which are consensus, node, fork, sidechain, blockchain, and timestamp. And in these two parts, I will connect again with my very brief speech of yesterday. I will try to explain why blockchain is a very bad term and a very confused term, and why the alternative term that Satoshi Nakamoto used instead, which is time chain, is way better. And the timestamp, which is also a very confused term about the function of a blockchain. And then censorship and censorship resistance. So let's start. What is consensus? You can read a lot of debates about consensus. People talking like, the consensus defined the network. This implementation is violating the consensus. Basically, when you have people talking about consensus, what they mean is a confused mix of very, very different things. Some of them actually imply the ordering consensus, which is what is called Nakamoto consensus in scientific papers. Nakamoto consensus is not about the kind of rule, it's not about agreeing on the rules of Bitcoin. It's not about agreeing on what Bitcoin is, how Bitcoin works. Nakamoto consensus is only agreeing about the chronological order, of the unique chronological order of the valid transactions inside the Bitcoin blockchain. So if you have your Bitcoin node, the Bitcoin node will reach Nakamoto consensus with other nodes by first filtering out all the invalid transactions. So in this case, consensus doesn't define validity. It depends on validity. First, the node will just exclude any invalid transaction. And then they will use hashing power majority and proof of work in order to just order the transaction in a way that prevents double spending. So this is a very strict sense of the word consensus. Basically when your Bitcoin node falls out of consensus in this sense, it just means that you somehow are following not the heavier valid chain, but a lighter valid chain. So you're out of consensus because you're following a orphaned chains or a stale chain, basically. When there is a reorg and you thought that you have been paid, but then there is a reorg. So assume that you get your Bitcoins, then you wait for 6 confirmations, you are happy, but now the CEO of a scam exchange gets hacked, and now he bribed the miners to undo any reference to real people or real events is completely imaginary. and they undo the chain for 7 blocks. Okay, in that case, you're out of consensus because your consensus is not valid anymore since the new, longest, heavier valid chain is the other one. Some people instead are not talking about chronology consensus. They are talking about validation consensus, validating consensus, validity consensus, which is agreeing about the consensus rules. So these are two very different things. In the first case, your Bitcoin software will use proof of work in order to determine which one of the valid transaction is double spend or not. But in the second case, your Bitcoin node will not use proof of work at all to define validity consensus. When you want to be in consensus with the rules of Bitcoin, there is proof of work has literally nothing to do with that. Do you remember during the New York New York agreement attack, there were people, like famous people in the industry, sending email saying that Bitcoin, the valid Bitcoin chain is defined by the heaviest proof of work? Well, that's not absolutely how Bitcoin works. If your Bitcoin node receives a invalid Bitcoin transaction, it doesn't matter if it has the more proof of work than any other chain in the history. If it's invalid, and your software will just refuse to accept it. So validity has nothing to do with proof of work. The Nakamoto consensus is only about chronology, and it is not about validity. Validity is another kind of consensus, and sometimes developers use the same word to indicate both, which can be very, very tricky and can create a lot of misconception, a lot of misunderstandings, even between people in good faith. Then there is people using the word in a third sense, in a third meaning, which is basically developer consensus. So, for example, there is this rule in Bitcoin. For example, the size, maximum size of a block, or the frequency of the blocks, or whatever. And the rule consensus is that this block is valid and this block is invalid. Then we want to change that, and so we can try to measure social consensus among developers, among stakeholders, among miners. So, for example, we want to move from a CDSA signature to Schnorr signature, or to Taproot, or Graftroot, or L2, or whatsoever. In order to do that, we have to understand if there is what is called rough consensus. This is a terminology that was used as well during the development of the Internet protocol. And in the Internet protocol, one of the things that was typical of that development community is that they didn't vote about a protocol feature. It's not like it was not a democracy. There was this rough consensus emerging. They were basically collecting technical objection and technical opinion and feedback, and it's very difficult to measure this. So these three things are completely different. For the first thing, the chronology, everything you need is proof of work. So hashing power is king in the first kind of chronology. For the third kind, it's actually very difficult to, there is no an easy way to find a social consensus. There is not even an easy way to measure social consensus. You cannot know that there is consensus basically until after you know it, because it works. So let's assume you propose a change in Bitcoin. How much ACK, how much ACK do you have to receive in GitHub in order to get consensus by the developers? There's not a clear term. Let's assume that you want, for example, unanimity. A modification in the rules of the protocol is accepted only if everybody agrees. But what does it mean, everybody agrees? If you mean literally everybody on the internet, then you created an attack surface because everybody that wants to stop you just have to say that it disagrees without no reason, and so they basically stop you forever. Think about SegWit. When people implemented segregated witness, there was a technical debate on GitHub. Technical people were debating, they were discussing, and at the end, they arrived to a total 100% consensus among developers about segregated witness. That means that there was no single technical objection. So they said, okay, we can go. Now, there was one objection actually by Luke Dasher about the block discount, the witness discount. Luke was disagreeing, but at the end he said, it's okay, we can go on. So after there is full technical consensus on that, what they do, they ask the miners to signal that they are ready to adopt the new consensus protocol. And the miners, especially Bitmain, the miner, the ISACs monopolists, they used this signaling mechanism, which was a safety signaling mechanism, not a voting. They use it to vote about, yes, I agree or I disagree. But the discussion among technical people already reached full consensus among developers. So it's kind of... Oh yeah, so the second is actually the second is the simplest one. For the first you need hashing power. The third is very complex social dynamic. The second is just your node based on what happened to the third level. Your node will just enforce automatically the second layer. So unless you have a bug in your implementation will enforce automatically always. So in the second sense, your node defines consensus for you. If your node defines that you are adopting a soft fork and I pay you with a transaction that violates the new rules, your node will just reject it. So your consensus in this case is kind of local. You can define your consensus. Of course, it's better if your consensus is everybody else consensus. Otherwise, you're not using money. But you define the second consensus individually. While in the first case, you have to ask for the hashing power majority. This is a very strong difference because in order to have these, you just need your local software on your computer. While in order to reach these, you have to communicate with the network in order to know which is the heaviest chain, because the valid chain is the heaviest valid chain, not the heaviest invalid chain, and not the lightest valid chain, but the heaviest valid chain.
Short question. In the second case, the rules that are built in your software, that they define consensus.
Yeah.
But you should also ask the other opinions.
Well, that's the third level. At the second layer, if your Bitcoin node enforces some rules, that's the consensus you are on. If nobody else enforces SegWit, but you do, I mean, the way SegWit was coded is that you don't enforce that unless everybody else enforces as well with the signaling mechanism. But in theory, if you change your software to enforce some rule, your software defines that consensus for you or for everybody agreeing with you. You can fork off the consensus of Bitcoin, and we will discuss the word fork in a while, alone without any hashing power, just changing the rules. Of course, there is another meaning, which is a scam conference in New York, mostly about shitcoins and private blockchains. But this is a very specific meaning, so we don't have a lot of confusion. So second terminology. Strict definitions are basically, we can put some order here by using three definitions that are sometimes used, which are project consensus. So this is the third level. So the social consensus about which direction choose for a project. Then there is the rule consensus, which is enforced by the node. And then there is the chronology consensus, which is enforced by the miners. They are the same things. I just switched the order and changed the name. The state of the art about this term is kind of bad. I think that if you look for debates on Twitter or Reddit about a disagreement, you can find a lot of examples. I myself found a lot of examples of people disagreeing, mostly because everybody was meaning different stuff when they were saying consensus. So it's very chaotic. And the implication in debates are huge. For example, the big lie that what defines rule consensus is hashing power was used in order to carry out an attack on Bitcoin. And many people weren't clear on terminology in order to understand what the hell the other party was talking about. So I think that in Bitcoin Wiki, you can find some terminology, in bitcoin.org glossary as well. So you can look it up and try to understand what is people talking about when they say consensus in Bitcoin. It's very important to have it right. So now we switch to node. When people say Bitcoin node, they mean a lot of different things. Gabriele gave, I think in Kiev, was your presentation about the different kinds of nodes. Satoshi originally in the paper, in the white paper, and in the first comments of the code, was calling nodes some software daemons that were basically doing everything, from mining to validating to key storage to transaction signing, coin selection. The Bitcoin software, Bitcoin basically the first Satoshi client was doing everything. So when you read the node in the white paper, what it means is a software running which is doing any function in the network. But then actually many people, especially now, use the term node to indicate very different things. And there are, for example, full archival nodes are nodes that store and validate all the Bitcoin blockchain. So you have your Bitcoin core at home, not pruned, and there you have an archive of any single block of the blockchain, the whole valid history of Bitcoin so far. This is, for example, very important because when your node when you want to sync your new node, you have to ask to other node, and you need to reach out for full archival node in order to get from them the full history that you can validate yourself. Otherwise, you are trusting somebody, and the system is not trustless, and it's easy to attack. But then there is also the pruned node. The pruned node is the same of a full node, so you validate all the history, but you don't keep all the history. You download all the history, you validate all, but then you delete some things that you don't use, basically. So you just keep the final valid state, and you give away all the information that you don't need anymore in order to understand if you have been paid or not. Then there is another kind of node, which this discussion is especially useful when you debate with shitcoiners. For example, many of you, I mean, how many of you run a full Bitcoin node in this room? So it's not many, but I would say a little bit less than 20. So how many of you run locally on your machine a full validating Ethereum node?
I was trying so long to synchronize.
Okay, so one. No,
That's
that's important because so the full validation node, for example, in Ethereum means at least two things. The equivalent part of Bitcoin will be full archival node, and basically Vitalik said that not even the Ethereum Foundation is keeping anymore an archival node because it's too big. And so there is the pruned node, and there is also something which is called assume valid, which is also used in Bitcoin sometimes, which is basically a checkpointed node. So since it's basically impossible to synchronize the entire chain because it's too big to synchronize, then we trust for old enough transaction, we trust basically developers that will put some arbitrary checkpoint before which you will not download and validate. This is something which is practical, but very, very dangerous because basically, if you take over the programmer, basically the maintainer that is providing the checkpoint, you can perform some sneaky kinds of attacks. Of course, Ethereum is very complicated because in theory, from the prune node, you can recreate the archival node, except that you will need more resources than anybody has, even at NASA. But anyway, let's stop talking about shitcoins and get back to the point. There are checkpoint node is people that thinks they are validating everything, but they are validating everything only if you assume that they have not been attacked up to a certain point in time. And then from that point on, they are actually validating. Then you have what is called somehow improperly lightweight node or light node. Light nodes are nodes that are not validating anything, basically. So when you have a Bitcoin wallet in your cell phone, some people like to call this Bitcoin wallet a node. Like this is a node, this is just a lightweight node. It was Mike Earn mostly to frame this kind of terminology. This is a very misleading terminology because that stuff is a wallet because you are storing key, you are signing transaction, but it's not a node of the network, of the consensus network at all. Basically, what you are doing with your lightweight node is just trusting somebody. In the best cases, like mycelium, like I think Electrum, even if that discussion is a bit more complex, you are trusting somebody that you know who it is. In the best case situation, you have your own server. So for example, you use Electrum with your Electrum server and you're trusting yourself. So you're trusting your full node. Or you use Green with your Bitcoin Core and you're trusting your full node. In the second best case, for example, a Ledger, a Mycelium, you are trusting somebody, but you know who is. For example, you are trusting the Ledger server, which is bad because Ledger could attack you if required to attack you. But I mean, realistically, probably there is no reason for Ledger to attack exactly you right now. So you can trust them maybe for a while. But there is even a more dangerous situation, which it's the worst situation ever, which is basically just trust the minor majority. So this was also created by Mike Hearn. And the idea is, instead of checking if your transaction is valid or not, just check if your transaction is mined by the miners or not. If the miners mine it, that means it is valid. If the miners don't mine it, then it's not valid. The problem with this approach is that in the original security architecture of Bitcoin, everything that a dishonest minor majority could ever do was just reorging the chain. And reorging the chain basically means that you can double spend your, so let's assume that one of you is Jianwu, now Jianwu is probably, I don't know, working at McDonald's, but let's assume that you are Jianwu when he's still the CEO of Bitmain. And what can you do? You can only steal your own money double spending me. So you can also defraud people with double spending, which is bad, but it's not so bad because you cannot take other people's money. You can only take your own money. Or you can try to censor transaction for a while. For example, there is the address of, you know that now Peter Schiff, the gold bug, he said, I hate Bitcoin, but then he published a Bitcoin address and everybody started to donate to that address. So let's assume that you are a guy who controls the majority of the hashing power and you want to punish Peter and you want to censor transaction from his address. So you can do that as long as you have 51%, 50% or more of the power. So the minor majority, a cartel controlling minor majority, which is a very realistic situation because, you know, mining is quite decentralized, but the production of mining ASICs, as you know, is quite centralized right now. It's very expensive to create a mining ASICs. So for this reason, if you are a miner monopolist, an ASICs monopolist, you can control the majority of hashing power pretty easily. For example, Bitmain arrived to the 80% of signaling of the NYA attack because it was basically blackmailing mining farm. They were saying, unless you signal what I want, I will not sell you other equipment. So they were the monopolist of the production, so they were in a very strong position. But the Bitcoin architecture is not so bad because even if you have a dishonest majority of miners, still all they can do is a reorg, which is bad, but not so bad. There are some economic countermeasures. Why? If the majority of the economy, instead of validating the rules, just trust blindly the miners, that means that any people that can reach 50% and more, 51% of the hashing power, they can do everything. They can rewrite the rules entirely. They can inflate the total supply, not 21 million, 40 million, without you even knowing that. They can inflate supply of money in stealth mode. They can steal your money and you cannot do anything because other wallets will not check that they are stealing your money. They can steal Satoshi Nakamoto's money. They can do whatever. So it's very important to understand that if you use this terminology of node, your node is not actually validating anything. In a best case scenario, they are trusting somebody. In a super best scenario, they are trusting your node at home. In second best scenario, you are trusting some known party, which is okay. And in the worst scenario, you're trusting you don't know who. You're trusting some unknown mining majority. So maybe you're trusting Bitmain, but you don't even know that. So that's the very dangerous systemic risk. Then there are basically the non-validating wallets. These are in a way more, still there, a little bit more honest. So basically, you have a little software. You know that everything that this software does is just signing transactions and nothing else. And you know that in order to validate, they will speak with a node on your computer. So you can have, for example, if you use a Lightning node right now with Zap or with Spark application, there is not a Bitcoin node on there. There is just a remote control which will talk with your Bitcoin node at home, which is probably the best architecture so far. And then there is the custodian account, which is when you have, for example, a Zucco app on your phone, then you are not validating rules and you are not even storing keys. Everything is done on server side, and you don't own Bitcoins. You own credit denominated in Bitcoin. So you own a promise by somebody to give you Bitcoin when you ask it, which may be a honest promise or not. Also there is well, I will go faster here, but when we talk about Lightning Network, we have another complexity about node, because now we have the Lightning Network nodes, and this is even a little bit more complex. But basically, this is the distinction. So the state of the art in this situation is better. For example, nobody technically competent will call a miner a node anymore. So the terminology used by Satoshi originally, in which you had everything inside, everything packed in one single software, is not used anymore. People usually now, they use node to indicate only the Bitcoin full node, while the miners are called miners. It's interesting that Bitcoin nodes, they don't generate Bitcoin blocks because they're not miners, but they do validate Bitcoin blocks. While Bitcoin miners, in theory, hashers, they don't validate anything. Sometimes you can read in the articles in the news, miners validate Bitcoin transaction. Miners' job is to validate transaction. It's not like that. Your ASICs doesn't do any kind of validation. They connect to the full node of the mining pool. The mining pool node will do all the validation. They will serve some kind of block to the ASICs, and the ASIC will just do basically a hash collision. So there is no validation inside the miner. There is only confirmation, only proof of work commitment. Validation is zero. Validation is only in the nodes. So the situation here is not so bad. Maybe the only problem is that people sometimes confuse validation with verification. So people calls SPV when you ask miner majority, but SPV originally means simple payment verification. But when you have an SPV wallet, you are not doing any verification. You are just trusting the money majority. So it's a little bit strange to call it SPV. Also, there is somebody who didn't understand how node works. For example, people counting nodes during maybe social consensus debates. There is people saying there are 50% of the nodes are okay with this implementation. No, now 80% of the nodes are more like this. Like you can count nodes in order to define consensus, but that's not the case, because as you know, anybody can just go on Amazon AWS and fire up 200 nodes right now in a few hours. The number of nodes in the network doesn't mean anything. You can trivially fake this kind of metric. And also there is some misconception in calling very big Lightning Network node, they call them hub. Like, the problem of Lightning Network is that you have very big hubs centralizing the routing. Using the terminology hub is very wrong for this situation. Terminology node is better. But let's move basically to the next word. The next word is fork. So when you read right now in newspaper, there is a new fork of Bitcoin. This exchange is listing or delisting a fork. So Bitcoin Satoshi's vision is the fork of Bitcoin, etc., etc., etc. Basically, the mainstream, the crypto mainstream media are using a terminology which is very, very, very misguiding. For example, what is Bitcoin Satoshi's vision? Of course, it's a fraud, it's a scam. But what is Bitcoin Satoshi's vision from a technical point of view? It's an altcoin, which means that it doesn't follow Bitcoin's validation rules. It follows different validation rules. and it is a UTXO-based airdrop distributed altcoin, which means that instead of forking away to block 0, like Litecoin, they fork away to block X. For example, in Bcash, the block is, I don't know, 15,000 something, and then in Satoshi's vision is higher. So the only difference between Bcash and Litecoin is that Litecoin diverged the UTXO story at block 0, and other forks, they divert the UTXO distribution later on in an arbitrary point in history. But they are no different from other kind of altcoin. There is no reason why Bitcoin Gold is more Bitcoin than Litecoin. It's just a marketing decision to use the name Bitcoin in the name. Sure, they did an airdrop, but even a lot of altcoins did airdrops, like I don't know, Stellar, Ripple, they did airdrops, Byteball, you name it. Aurora coin, the next Bitcoin, right? So there is also a different kind of definition for fork, which is basically a fork in the consensus of Bitcoin. And this is kind of difficult because basically it follows the same division that we spoke about consensus before. As we said, there is, you remember, there is the project consensus. So developers are agreeing and users are agreeing on something. Then there is the rule consensus. So this node is enforcing these rules. And then there is a chronology consensus. And you can have a fork in the all three different meaning of this word. You can have a project fork, means that I took a project, for example, GitHub, and I fork your project. It just means that usually I take your project idea, and I reuse something of this idea and I change it to do my own stuff. For example, the typical GitHub name for the GitHub meaning for fork, when you are forking a repository on GitHub, it means that basically you are taking a project, you are creating a different project which is reusing a lot of code, and you are changing the future history of the project. But then there is the rule fork. Rule fork means that not only, for example, you can go on GitHub on Bitcoin Core. There is the Bitcoin repository. You can fork the project, but you can keep the same rules. For example, Bitcoin Knot is a fork of Bitcoin Core maintained by Luke Dashier. It is a fork of the project, but it doesn't fork the rules. It keeps the same rules because every transaction which is valid in Bitcoin Core is also valid in Bitcoin Knot and the other way around. So you can fork the code, or you can fork the rules, or you can have a fork in the chronology, which is basically just the same rules, but one part of the network thinks that the most heavy chain is this, and one part of the network thinks that it's the other one, basically for a reorganization. So this is a chronology fork. Chronology forks get resolved automatically with Nakamoto consensus. While a rule fork, they don't get solved. Basically, the network diverges forever. And project fork, they don't necessarily create any rule fork. You can fork Bitcoin repository without forking Bitcoin rule. So now, when people talk about hard fork and soft fork, this definition, hard fork and soft fork, only applies to the rule fork. So you cannot go to a repository and soft fork Bitcoin Core. That doesn't make any sense. But you can soft fork the rules or hard fork the rules. So that's about rule changing. And you have typically two kinds of forks in this way. Soft fork is when the new rule consensus of Bitcoin is stricter than the old rule consensus. So basically, every transaction that is valid now was also valid before. So it's completely backward compatible. But some transactions that were valid before are not considered valid now. So this is a soft fork. While the hard fork is the other way around. In the hard fork, you are basically expanding the rules and not tightening the rules. So every transaction which is valid under a hard fork may have been invalid before, and every transaction that was valid before is also valid now. Of course, it's not so simple because, for example, there are things called soft hard fork and forced soft fork or evil soft forks or extension blocks. So this, I will not go into details about that, but if you try to Google what is a evil soft fork or what is an extension block, you will see that the simple definition between hard fork and soft fork is not so clear cut. There is a lot of ambiguity here. There is this funny things that in Bitcoin terminology, hard fork and soft fork, so rule forks, they don't mean project fork. So, for example, Bitcoin Gold is not, technically speaking, a hard fork of Bitcoin, because when you have a successful hard fork, you don't end up with two different coins. A successful hard fork is the one in which Bitcoin is still one, but with a different kind of rules. So we had some kind of Bitcoin hard fork back in 2012 or 13, but it's not the same. I mean, Bcash, BSV, they are not hard forks. You could say that a failed hard fork attempt could create an altcoin. But BSV and BCH, BGold, they are just altcoins with an airdrop distribution. They are not hard fork. Of course, the situation is, the state of the art is pretty bad, because now there is a globally accepted terminology in which people calls every airdrop altcoin hard fork for no specific technical reason. So in newspaper, in articles, in crypto stuff, you will read that Bitcoin Gold, Bitcoin Diamond, Bitcoin Private, and all this shit, they are a fork, a hard fork of Bitcoin. That's not technically correct, but I mean, whatever. Some definition is still, I mean, there is not a well-defined definition about this stuff. Some developers will use the term hard fork, soft fork, heavy soft fork in a very confusing way. So if you try to go to the IRC channels, if you try to understand what people means with any terminology, you will see that it's a mess. So if somebody can come up with some kind of unified terminology, that's there is a lot of controversy right now. So let's talk a few minutes about side chains. So one of the reasons I go back a little bit, because one of the reasons I wanted to start with this presentation, I was triggered a lot when I've seen this. Basically, Charlie Lee, which is I mean, it's a nice guy and everything, but he said that Lightning Network with atomic swap makes Litecoin effectively Bitcoin's sidechain. What? I mean, are we sure? So Lightning Network with atomic swap makes Litecoin a Bitcoin sidechain. And then there was like Ricardo Spani saying, what if I told you that Monero is a sidechain already? It has been from the beginning. The devs just haven't enabled merge mining at this stage. So everything that has merge mining is a sidechain. So Namecoin is a sidechain. I mean, that's kind of fishy. So I have some other collection of ambiguity, but the main point is that basically sidechain is now a very, very strange definition. So for somebody, especially the two gentlemen I just mentioned here, sidechain is basically something somewhat related to Bitcoin. So if you, I mean, words are. So what I want to stress is that I'm okay with this definition. It's like yesterday I said about blockchain. So you can call your database a blockchain. I'm not mad at you if you do that. But if you call a database a blockchain, you should, you know, there is the best private blockchain I ever seen is the website www.myblockchain.xyz. You should go there and try it. It is a fork of MySQL where they changed the tables. Now they are called blocks. And the records, they are called transactions. And everything else is MySQL. And it's a private blockchain. And it's very funny to look at the description, the FAQ. So do you want to call everything a blockchain? You can. But if you do, you have to be consistent. And you don't have to give a special meaning to this word anymore. Because if anything using cryptography is a blockchain, then we already had blockchains in the 80s, which is cool. But don't give blockchain any special meaning anymore. Because in that case, blockchain is not immutable, not disruptive, not revolutionary. So the same thing applies here. Do you want to use the term sidechain as something somehow related to Bitcoin? That's fine by me. But don't charge then the name sidechain with some kind of expectation or importance, because there is a lot of stuff which is somehow related to Bitcoin. So Some people instead use the term sidechain. Riccardo Spani was falling in this, Fluffy Pony was falling in this second kind of misconception. It was calling sidechain everything which is merge-minded. Merge-minded, I don't know, I mean, raise your hands if you know what merge-minded means. Probably many of, not so many. So I'll try to be super quick. Merge-minded means that instead of, when you want to create a scam coin because you want a Lamborghini, but now you don't want to bootstrap a new proof of work network from scratch because it's difficult. So what you do is this. If you take a block, a side block, not side, if you take an alt block in your altcoin, or to be more consistent, a shit block in your shitcoin. So you take the shit block. So now you go to, you are a Bitcoin miner. Inside the Coinbase of the Bitcoin block, you put a cryptographic commitment, for example, an hash or a Merkle tree or a Merkle root of your shit block. So now all the shit nodes, they will reach consensus about the chronology, not looking at the shit chains, but looking at the actual blockchain of Bitcoin, and they will check if the Merkle root of the shit block is included in the Coinbase of the actual Bitcoin block. So this is a smart way to leverage the Bitcoin proof of work. There are some concerns by some developers that that's not a very nice thing to do because it can create very bad centralization pressures. So this can be dangerous, but basically it's a nice idea in order to not have to re-bootstrap your proof of work chain from scratch, which is almost impossible. Basically, you end up very centralized with one guy mining everything, which is basically useless. The third meaning that people uses the word sidechain for is the only meaning with some kind of consistent technical history, which is basically, well, I don't list it here. No, so Charlie Lee was talking about atomic swaps, which is also wrong. The only meaning which is somehow consistent technically is everything which has a deterministic two-way peg. So sidechain in the original definition of the Blockstream paper is any kind of Bitcoin-like structure where the asset, the native asset, is not something new, but is something which is pegged two-way to Bitcoin. So in order to have your side coin, you have to basically freeze. So you have your Bitcoin chain and you have the side chain. You take a Bitcoin, you freeze it, and when you freeze it, the sidechain knows that you froze it, and so the sidechain will create a side coin, one for one. Then you move the side coin in the sidechain, then you destroy it, and when you destroy it, the main chain somehow will know that you destroy it, and it will unfreeze the original Bitcoin. Why is a sidechain very important? The sidechain concept was very important and was also very, there was a lot of expectation about sidechains when the paper came out. Because the problem with shitcoins is that when you want to try to create a shitcoin, you're not just trying to recreate from scratch some technological architecture, which is already pretty messy. I mean, when you want to recreate a cryptographic primitive or an infrastructural standard, you will end badly. You will end to mess up something. So recreating architecture is already bad, but it's not so bad as sometimes you have to experiment with new architecture. But the problem with shitcoins is that every time you want to recreate an experiment with a new architecture, you also have to reinvent money, basically, and to bootstrap a new financial assets from scratch, which will have to redistribute its user base. It will have to do the price discovery in the markets again. You will need liquidity. You will need the market depth. You will need financial instruments to limit liquidity.
Bribe some exchanges.
Yeah, you need to bribe the exchanges in order to fake liquidity in your token. And so that's the problem, because it's bad for you. If your shitcoin project is honest, creating the shitcoin is bad for you because you are rebootstrapping economy from scratch, which is not needed if everything you wanted to do was just to experiment. Like, I don't like proof of work. I mean, I don't like 1 megabyte blocks or 4 megabyte blocks. I want gigamax blocks. I can create a new infrastructure, but why do I have to bootstrap from scratch a new form of digital scarcity? That's crazy. It's bad for you, and it's also bad for everybody else, because this kind of economical singularity will attract scammers like a honeypot. If you create a project when you are not printing money, then mostly you will attract competent people interested in the project. But if you create a project when you are printing money, even if you are honest, let's assume that you are a very honest shitcoiners, but still you will attract these honest shitcoiners like honey, because that's just how economical incentives works. If you are printing money, everybody wants to be close to the money printer, not because they are interested in technology. I mean, you know the meme, right? I'm here for the technology, the golden chain. This is the right definition. The situation is pretty bad right now, especially because doing a deterministic two-way peg in a trustless way proved to be kind of unfeasible for now. There is a big problem that is unknowledge inside the Blockstream paper, but it was never really solved, which is this. If the Bitcoin node, they have to, so the sidecoin node, the sidechain node, they will have to be also Bitcoin nodes. So everybody running a sidechain, they will also be running Bitcoin. So when Bitcoin is frozen in a escrow, in a side coin address, then the sidechain node, they know that the coin is frozen and they can create the side coin. But when the sidechain destroys the side coin, how does the main chain node know that the side coin has been destroyed? You cannot ask to Bitcoin node runners to run also every side chain. Otherwise, you are just, running a side chain in which you ask every node of Bitcoin to run the side chain node is like just increasing the block size. It's nothing different. You're just asking Bitcoiners to do more validation with more bandwidth problems and bottleneck problems. So this doesn't work very well. So what was the theory behind the Blockstream paper? It was
what's rootstock?
so rootstock, yeah. So let's step back a little bit. The original Blockstream paper wanted to do this approach. We used the full consensus of Bitcoin to create the side coin when the Bitcoin is frozen. But when the side coin is destroyed, we don't need to check the validation of that destruction. We just need the miners to prove that the side coin was destroyed. So it was like a SPV-like security, which, as we said before, is very, very bad. So when miners were considered less dangerous attack surface in Bitcoin, it was possible to imagine a hash rate based. So, you know, the problem is not the one-way peg. To go from Bitcoin to the side chain is pretty easy. But to go from the side chain to Bitcoin, that's pretty difficult because Bitcoin doesn't know and doesn't care and doesn't give a fuck about the side chain. So it's very difficult to come back. So you can use escrow, hash power escrow, drive chain, SPV chain, but they are very insecure. So Blockstream changed the idea to something new, which is what the Rootstock also used, which is a federation model. So the idea is this. You select some kind of federation where some people, basically, you select 10 people, 100 people with an address. Then you create a multi-sig address, for example, I don't know, 12 out of 15 or something like that. And the Bitcoin are blocked in this multi-sig escrow. When that's happened, the sidechain will automatically create the side coin. But when you want to go back, the federates, you have to trust the majority of them. They will not lie about the fact that the side coin was destroyed. So if they see that the side coin was destroyed, they will release the Bitcoin. Otherwise, they will not. There is a little problem with this, is that if you assume that the federation is honest, then you don't need a blockchain anymore, basically. You can just, why do you need proof of work, merge mining, or whatever? If you have a group of people which are trusted with the value of the asset, because they can actually give you the convertibility of the asset, just trust them already to sign the transactions. So they can sign transaction in blocks like they do in Liquid, but they can sign transaction without blocks. I mean, you don't need the blocks, you don't need blocks, and you don't need a chain. You just need people signing stuff. So basically, this concept of sidechain is way better than a shitcoin because you can create a technological innovation without generating a new shitcoin, but is not as good as the original sidechain idea because it's completely trusted and you are trusting a static set fiduciaries, which is basically centralization. Rootstock is the same. The main difference that is the kind of code that runs the sidechain, the federation. In Rootstock, the code is the EVM, is the Ethereum virtual machine. So you take Bitcoin, you freeze Bitcoin in multisig, you generate a smart Bitcoin as Bitcoin, which is a side coin in the Rootstock multisig federation. Then you move this Bitcoin with Ethereum EVM, so you can do all the great smart contracts of Ethereum. So you can lose your Bitcoin in the parity multisig account. You can create the DAO. You can do all the fun stuff that you can do on Ethereum. Yeah, a CryptoKitties, of course. And then when you are finished, if you have any money left, you can get back with the federation model. Blockstream Liquid is different because instead of using Ethereum-based code base, they use the Bitcoin Coinbase for a reason of interoperability upstream. Basically, the idea is if we want to experiment crazy stuff like confidential transaction, confidential asset, Mimblewimble, Segwit back then, we keep our federation code the closest possible to Bitcoin code, so we can reuse all the great Bitcoin code which have been heavily reviewed over the years. And when we find something interesting, that something interesting can be trivially switched to the actual Bitcoin. So Liquid copies Bitcoin code, Rootstock copy Ethereum code. Also, Liquid uses hardware in order to make the federation a little bit less trusted, because the federation is running these boxes and there are tamper-resistant boxes. If you try to tamper, they explode with termites. No, they don't explode, but they break down, and they are very difficult to tamper with. While Rootstock uses a simple federation without HSM, so it's a little bit more easy to tamper with it. So the only problem with this distinction, with this evolution, is that there is a very good article on the internet. It's called "Is My Sofa a Sidechain?" The article is from Jay Stolfi, which is, he is a troll, he is an anti-Bitcoiner, but this article is very funny. We are redefining the sidechain concept so much that basically, is a Kraken account, is one Bitcoin on Kraken a side coin? Is Kraken a sidechain? Yes, because their cold storage is a multi-sig, exactly like Liquid multi-sig. So they are both multi-sig scheme. It's just that Kraken cold storage is a very simple multi-sig scheme, while Liquid is a very complex, advanced, and smart multi-sig scheme. But why do you call it sidechain? You don't even need a chain anymore. You can create a federation where you don't have blocks and you don't have chains. So the terminology is probably losing a little bit of, I would probably suggest to stop using sidechain term altogether if it was on me. It's not on me, so we will see. So blockchain, I already told about blockchain yesterday a bit, so I will not repeat myself, but you have still the same kind of problem. Somebody uses blockchain to indicate whatever uses something somewhat related to Bitcoin. So in this kind of meaning, if your system is peer-to-peer, then it's a blockchain. So BitTorrent is a blockchain, right? Or if your system is open source, then it's a blockchain. So Linux kernel is a blockchain. So if your system uses digital signature, that's a blockchain. So PGP is a blockchain. If your kind of system creates some kind of economic incentives like Bitcoin, then it is a blockchain. So Reddit Karma is a blockchain, or World of Warcraft Gold it's a blockchain. If your system uses some kind of linked timestamping in which some state gets hashed into another state to create an hash dependency, that's a blockchain. So guard time, which was basically an interesting, guard time was a company. You take your document, you hash your document, you give it to guard time, and guard time will publish the hash of the document of the advertising section of a very famous newspaper. So basically what you do is timestamping your document using newspaper, because then you cannot go back and change time. Is guard time with paper a blockchain? Again, if you want to use this very loose definition of blockchain, be my guest, but then don't try to put any kind of special meaning, because everybody's using blockchain since the 20th century, basically. The second kind of stricter definition, so there is a, Peter Todd is using a definition which I think is very, very broad yet, because he still wants to be called a blockchain consultant because it sounds cooler. But most of the things we do with cryptographical linked graph of physical records is actually nothing new and nothing related to what Bitcoin actually does. In the state of the art, I think that the clarification is badly needed, and that's why, I mean, the problem with the broad definition is that yes, you are using a blockchain, but that doesn't mean anything. The problem with the strict definition is that basically you never need a blockchain for that. So I remember the sentence that Kevin Locke was repeating during a Chainsmith's hackathon in Dublin. Basically, there were, I think, 100 projects, and then we use the blockchain to do that. You don't need a blockchain for that. You just need digital signature. But we use the blockchain to do, you don't need a blockchain for that. You just need the timestamping. But we use the blockchain, no, that's just being open source. That's not a blockchain. So the problem of this definition is that it's very strict, and basically nobody needs a blockchain ever, except just people paying with Bitcoin sometimes. Because the cool thing about Bitcoin is that the more we evolve Bitcoin, the less we need the blockchain. So you think that, you know, when you read the newspaper, like the new evolution is blockchain without Bitcoin. Actually, any kind of technical research is going in the opposite direction. Using Bitcoin without blockchain, or with the less possible use of the blockchain, because the blockchain is slow, inefficient, non-private, a lot of fungibility problems, and very, very, very expensive. So what you do with Bitcoin is try to take stuff out the blockchain as much as possible. So for example, Mast or Graph Truth or Taproot, scriptless script, they are ways to take the Bitcoin smart contracts outside the blockchain. Lightning Network is a way to take everything except the opening and the closing outside the blockchain. Every interesting project in Bitcoin right now is to take stuff out of the blockchain. So you don't need a blockchain if you don't use Bitcoin, and probably you don't need a blockchain if you use Bitcoin. You will be better off without. So that's why yesterday I was stressing the idea. You can go back to watch the video of yesterday about the origin of the term time chain. Actually, Satoshi Nakamoto never used the term blockchain. He used that 0 times. And he used like 20, 25 times the term time chain, which is better because I think it explains better what a blockchain does, which is just establishing a unique chronology of events. So last, I think it's last, no, it's there is just one after this, is timestamp. As I showed yesterday in my speech in BIP, even if I love the term timestamp, time chain, Peter Todd hates the term time chain. Why? Mostly because many people doesn't understand what a timestamp is. And these people also includes the great Satoshi Nakamoto himself or themselves. In the Bitcoin white paper, you can read Satoshi Nakamoto defining the blockchain, so the time chain, as a distributed timestamping service. But that's not correct. What the blockchain does in Bitcoin is not timestamping, but it is proving a publication. I will try to explain the difference between proof of existence, which is timestamping, and proof of publication. Let's say that you are a shitcoin trader. So now you go on Twitter, you are a pseudonymous shitcoin trader. So you are called like Parabolic Panda, you're a dragon, you have a funny crypto Twitter name. You have the image of a hot girl, of course, and you go on Twitter to sell your trading skills. So you want to use the blockchain to prove that that you are very good as a trader. So what you do, but you don't want to give away knowledge for free. So what you do is you make a prediction, you hash the prediction, you put the hash of the prediction inside an op return in Bitcoin, then you wait, and the day after you reveal the pre-image of the hash, and you say, you see, this was the right prediction. I can mathematically prove to you that I can become the best trader ever in probably a few weeks with this. What I need to do is just to create basically for every prediction, for every day, I created 2 different documents. One says the Bitcoin goes up, one says the Bitcoin goes down. I hash both, I publish op return for both, and then I only reveal the one which is interesting. So this is precisely, if you have an identity, then it's not timestamping anymore. So timestamping only proves that some document existed on a certain point in time. But this proof is very, very weak if you don't have some kind of uniqueness of your prediction, of your expression, of your publication. So what you have to do is to say, people, look, for example, this is my public key, and I promise to you that I will only create op return transaction from this address to give you my hashed prediction. If you do that, people can check that there are no hidden prediction that you can reveal after. This is a technique that Peter Todd calls single-use seal. So basically, you create something that can be used only once, and when you use it, everybody knows that you used it. So basically, what you're doing is not proving the existence of a document. Not only that, you are proving the existence and the unicity, basically, of the document. You are proving the publication. You are proving that everybody knows that you committed to some data. This is very different from timestamping. Also, timestamping, if you think about that, is super scalable and super private, because when you have an op return, why do you want to timestamp only your documents? Since you have to spend for the transaction anyway, so you have to spend the fees for the on-chain transaction. So let's maybe aggregate 1,000 different documents of people that want to timestamp stuff. You create a Merkle tree of the documents. You take the Merkle root and you only timestamp the Merkle root. So you are timestamping. You can timestamp hundreds of thousands of documents with one Bitcoin transaction. Actually, you can do that without even using op return. There is some clever techniques that are called, for example, sign to script, in which you basically you change the signature in order to commit to your Merkle root. Or there is a pay to contract, which you change the public key you are paying to in a way that commits to your secret, to your pre-image. So timestamping is great because it's very scalable. Not many people knows, but Riccardo Casata and Peter Todd in May 2017, I think, they timestamped the entire internet during one meetup. So they created a computer program, a bot, that was going to the Internet Archive, and any single word in the Internet Archive, they put it in a Merkle tree with any other word with a website. They built a Merkle tree of the entire Internet Archive, all of it, and they timestamped it with one Bitcoin transaction. So with one Bitcoin transaction, you can timestamp the whole Internet Archive in a verifiable way. So timestamping is very scalable. While, for example, this is a typical example. MIT wanted to put degrees on the blockchain. So what they did first, they take a degree, they hash it, and they put it in op return. But the problem is that if you want to prove not just that the proof of existence, but also the proof of unicity, then you need to publish every single degree from a different public key. Otherwise, you have the collision problem. If you aggregate, you lose the proof of publication. So let's get back to my trading, my shitcoin trader example. I'm the shitcoin trader. I have to prove you that my prediction will be inside, will be signed by this the private key of this public key. But if I cannot aggregate, because if I aggregate, I lose the verifiability of that. So timestamping is very easy to scale, to aggregate, to make private, while proof of publication, which is what Bitcoin uses in order to avoid double spending, is very, very difficult to scale. It's basically unscalable because you need one block space, you need to consume block space for every single proof that you want to give. So let's go to the let's go to the last one, and so we finish, because I think we were, I mean, it's not 6 hours yet, but almost. So what does people mean when they talk about censorship in the context of Bitcoin? Even here, there is a very confused mix of different meaning of this word. Some people talk about censorship when they mean system censorship. So basically, when there is e-gold, e-gold was like a predecessor of Bitcoin. It was based on physical gold and digital signature to transmit the ownership in physical gold. The government came and shut it down. It came and it shut down also Liberty Reserve, which was another alternative. And you know, after a few years, I think like almost 10 years, the government comes and shut you down. The reason Bitcoin is decentralized is not because decentralization is cool. It's not because decentralization is efficient. Decentralization is actually inefficient if you think about redundancy. The reason Bitcoin is decentralized is that the government will eventually come to try to shut down everything which is centralized. Maybe not soon, maybe after 10 years, like with e-gold. So system censorship is when somebody comes and basically rule your system illegal, like a Napster. Somebody comes and censors Napster. Then there is a transaction censorship, which is something different. Transaction censorship means that I allow your system to exist, but I force you to censor, or you want to censor this specific transaction. So when we say that miners are censoring transactions, for example, they are not censoring in the first significance. They are not coming to your home, arresting you if you publish it. They are just denying the service of block space to your transaction. It's more like a market denial. They are refusing to give you block space, but it's not a government-like transaction censorship kind of situation. Then there is a confused mix of the previous two, and then there are these annoying people that confuses forum moderation with censorship. I know, I am sure you know a lot of them. You create a Telegram group which is about gardening, and then this guy comes in and he starts to talk about motorcycles, and you say, I mean, I'm not censoring you. You are free to talk about motorcycles, but please, I created a group. I put my effort in creating a group of like-minded people who want to talk about gardening. This is off topic, so I'm moderating you out if you insist. And I mean, if you call this censorship, that means that every time that somebody refuses to give you for free his scarce communication channel in order to broadcast your idea.
I turned off comments on my YouTube videos and I'm censoring people.
Yeah, exactly. Torn is censoring people because it's turning out comments.
I just turned them off.
But even, I mean, you write an article about philosophy. You send this article to the major philosophical peer-reviewed. I mean, can you do peer review in philosophy? Okay, let's talk about real science. Like, let's talk about physics. You create a physics paper. You send it to a great physics publication, and they refuse to publish it. Is that censorship? You create your comic, you send it to the national newspaper. You want your comic in the front page, but they don't want your comic in the front page. Is that censorship? No, it's people using their channel that they created and maintained as the heck they want. So this is not censorship. Of course, it's very while there is a lot of confusion between this confusion is a technical confusion between system censorship. So, for example, you can create. Let's think about eCash. eCash was an experiment, a digital cash in 1990, created by David Chaum. The server of eCash couldn't censor your specific transaction because it was blind. It didn't even know that the transaction was yours. So in the second sense, it was censorship resistant because it was unable to censor you. But the system itself was not censorship resistant because you can be a government, you can go to David Chaum, you can say, no, thank you, and you shut it down. The same went with the Linden Dollars or X.com, etc. So this is a technical distinction. This is mostly a bad faith rhetorical distinction. People making this distinction are usually in bad faith, and they are trying to impose their message inside the channel of other people. They're trying to violate moderation policy, claiming to be censored. I will not make any name here, of course, just a surname there. And so I think that was the last one. I will not go, yeah. Okay, there are many other terms to discuss. For example, the discussion about decentralization will be cool. There is a lot of confusion about decentralization. And the term trust is also very important to define. But if you think about that, what do you mean to trust somebody? When you trust somebody with your keys, that's one level of trust. When you trust your Lightning Network peer with the guarantee that they will not try to broadcast the whole state, that's another kind of trust. When you trust, I don't know, the miner not to publish double spending, that's another inferior kind of trust. So there are very different kinds of trust, and the next year I will use other 6 hours to do this. And well, yeah, open to questions now.
Hey, Giacomo, hold on. I have, I don't know if you saw this tweet from me from May.
Decided to work into the ICO, STO, EO startup pitch at ABC Summit. Just whoa, the blockchain enabled bike. The blockchain enabled bike. That's great. I mean,
The blockchain enabled bicycle.
please, a big round of applause for the blockchain enabled bicycle. Now it's a time chain enabled bicycle, which is all a different sound. Sure.
Is proof of stake blockchain still sidechain of Bitcoin?
So by the correct definition of sidechain, which, as we explained, when I mean, it's yeah. But with the strict definition, it doesn't matter how the consensus of the chronology on your chain is defined. So it can be proof of work, it can be merge mined, it can be proof of stake, it can be proof of authority like in federation, it can be whatever. The point that defines what a sidechain is in theory is the two-way, deterministic two-way peg. So the important thing is that the sidechain is not using a new coin, but is recycling Bitcoin, so you can experiment with the architecture without having to experiment with money, which is a difficult thing to rebootstrap several times because it creates bad incentives and so on. So in the strict terminology, you can create I mean, I know the proof of stake doesn't make much sense, but you can, I mean, go on and try it. You can try with proof of whatever, but the important thing is that you don't create a new coin. You're basically reusing Bitcoin. Oh, so this is an image about,
Do I need a fifth circle in this Venn diagram for sidechains now?
Yeah, now you do. Now you also, I didn't even discuss state chain. That are yet another stuff, another idea which is somehow similar to a federation, but not at all. So this is for next year. Other questions?
I have a question. A set of questions. Do you define, like, in the old definition and new definition, is blockchain or time chain is related only to Bitcoin, or it's a method or technology?
Well, even if I'm a very toxic maximalist, I will say that if you create a shitcoin that copies the functioning of a Bitcoin time chain, it's more than legit to call it a time chain as well. And I will leave the term blockchain completely open. I mean, I will like to promote a complete liberalization of the term blockchain. Stop feeling guilty, and let's consider everything a blockchain. So let's stop discussing. Time chain is probably only something which works like the Bitcoin time chain, which is basically something which creates an economical incentive for uniqueness. So what does it mean? That if you have a private time chain, for example, is not really proving any proof of publication because you don't have. So I try to go this way.
It does between the
Yeah, but then I mean, any kind of, then again, everything is a time chain. So the specific way that the time chain of Bitcoin works is you create a commitment to one version of history. Now you put money on this commitment using scarce resources, which is electricity. When you have put electricity, you get compensated by it with the block reward. So if you give up this kind of dynamic, you give up any cool terminology which is usually associated with blockchain. So for example, think about immutability. When you have a proof of work, a reliable proof of work time chain, then you have eventual immutability because basically to rewrite history, you will need exponential more resources going back in time. While a proof of stake chain, for example, doesn't give you any kind of immutability because you can just buy the keys, the long range nothing at stake attack. You can mitigate that with a blacklist, but you're not using that mechanism anymore. You are using auxiliary mechanism to avoid the long range attack. So I will define as time chain something which works like the Bitcoin time chain or the proof of work shitcoin time chain. Of course, when you use a proof of work shitcoin time chain, you should know that the immutability guarantee are not the same because the economical guarantees are not the same, because attacking a shitcoin is usually trivial.
My next question is,
Oh, Paul, come up.
my next question is, do you include the economic incentives and immutability into the definition of time chain?
I would. If I had to redefine now, I would, because what is time in this sense is a unique timeline of event, and it is unique because changing the past is expensive, and it is expensive because of the economic incentive.
Okay, I wouldn't fully agree with your words where you say that everything was we had blockchain in the past. Like we usually define it as the method to store and synchronize data between participants who do not trust each other. So like linking the past to each other was available, but consensus in the meaning of working according to the rules was not. So businesses never used these consensus techniques. They use replication, which is not the same. Some military systems use BFT consensus, but very few.
I agree with you.
And now where innovation lies is now we have the method of synchronization of data, reconciliation basically between participants that run like databases.
So I agree. I was already agreeing with you when you gave me this definition a couple of years ago here. Of course, I was kind of drunk, but I was honest in my agreement.
I received its signature. Yeah.
you didn't trick me into it with alcohol. So I do agree. What I did here is to use two extremes. So one extreme is everything is a blockchain. So we can have bikes on the blockchain. Everything is a blockchain. And the other extreme is only this very specific structure with this very specific set of incentives is a blockchain. Of course, you can stay in between and you can find some consistent definition in between. My problem is that definition in between, even if they are consistent internally, they don't really solve the sociological problem of avoid confusion, because some guy will still try to use this definition in order to move it. I mean, they will try to use their very centralized system using the term blockchain with some ambiguity in order to use the marketing power of the terms associated to the Bitcoin extreme, like immutability, disruption, permissionlessness, trustlessness. So you have the marketing. So you have two extremes. On one extreme, you have Bitcoin. On the other extreme, you have a centralized, completely centralized trust-based system. It's been even more a honestly centralized system, like the database of my banking account. So when I try to stay in between, what I get is usually the marketing advantage of both worlds. So I can pretend that I have the efficiency of the centralized system and the control of the centralized system, the reliability of the centralized system, the legal compliance of the centralized system, but at the same time, I can pretend I have the immutability, disruptivity, trustlessness, and permissionless of Bitcoin. Usually what you have from a technical level is actually the worst of two worlds. You have the inefficiency of a Bitcoin-like system. You have the useless Bitcoin stack with a lot of useless complexity and slow and error-prone situations, and the same kind of censorship exposure of a very centralized system. Ripple. Okay, this is Ripple.
Okay, I have three short comments. First, if you define time chain and include the immutability, and basically you're limiting this term only to Bitcoin, and then they become like the same, then you should call it Bitcoin, not a time chain.
But it's a part of Bitcoin. So I will use it as a term of Bitcoin technological stack. So Bitcoin is a technology working with digital signature, proof of work, time chain kind of linking of proof of work, and other minor technology like difficult adjustment, halving,
and economic incentives.
Which is part, I think, of
just like my question maybe for later is, how can we separate components of Bitcoin and say, okay, Bitcoin uses this technology, and this technology, and then it becomes Bitcoin. The second comment is that basically what private blockchain do, they do not They are not immutable in this meaning, in the full meaning. They're not permissionless, but they allow you to achieve level of transparency that wasn't available before. Just transparency. So indeed, you cannot prevent somebody from doing something bad, but you at least see who did what.
Tamper evident, not tamper resistant, but tamper evident.
And this is innovation. Okay, maybe it's obvious for engineers.
Yeah,
easy,
I mean, it was there before Bitcoin, right?
Yeah,
I mean,
yeah, it was there.
Git already had a hash link before
Except
Bitcoin.
consensus.
Yeah, exactly. So,
but consensus, Git doesn't have a consensus.
But still, it is tamper evident. If
Yes.
you try to change a past commitment in Git with the hash chain, you can show that somebody changed it.
Right. And the last thing that I feel that the communities, imagine that somebody invented a jet plane, not the propeller, but jet plane. And they created a jet technology, this turboreactive technology. And then basically this technology can be used for like ships, for rockets, for anything, not just plane, right? But I feel that we should separate generalize the technology and say, okay, this is applicable now for this set of like use cases. And then obviously the planes are very important. It's great to fly them, but there are also rockets and yachts and many other
I fully agree. My specific claim here will be, it's very strong. The claim will be that in Bitcoin, we don't have much of this situation. In Bitcoin, we have a technology stack which was collected from existing example and integrated with new stuff like time chain, with something that is needed mostly for Bitcoin, and it's working mostly inside the Bitcoin context. So I know that some technologies has a lot of fallout in other fields. I don't think that the Bitcoin specific invention by Satoshi Nakamoto can be used for much stuff outside Bitcoin.
No, sure.
There is another effect though. Gabriele told me about this effect 2 years ago. It was called the sailboat effect, right? So the sailing ship, okay. The sailing ship effect is this. So you have the sailing ship, it moves with the wind. It's the same since probably its evolution is very slow. Then you have the motor ship. You have basically the yacht industry, and they start to evolve very soon because the motor, the engine creates a kind of energy that needs new materials, new shapes. You need to work more. So what happened is that after the invention of the engine boat, the sailing ship industry had a lot of derived innovation. So the main innovation of the engine boat is the engine. So of course, you cannot say that the sailing ship is using the engine technology. It's not, because the engine technology is used for the motorboat, not for the sailing ship. The sailing ship is not using the engine, but is collecting some waterfall technological effect of technology which was created for to solve some new problems that the engine introduced. Some examples. Triggered by new competition, new money. So let's think about zero knowledge proof. So zero knowledge proof, like a generic zero knowledge proof, like Zucco's NARCs, they have not literally zero to do with the blockchain. Like the Bitcoin blockchain or time chain doesn't use encryption at all. It uses cryptography to sign, but it doesn't use encryption. So in Bitcoin, as is,
you know, the HSBC email that was sent like a week ago to all customers that say that Bitcoin is cryptocurrency is encrypted money.
Yeah, Bitcoin is not encrypted money. We hope we will become with some smart tricks like confidential transaction, but right now, Bitcoin, sadly, is not encrypted at all. Not even transactions are encrypted yet. We are working on encryption in the peer-to-peer level. So there is no encryption. There is only cryptography to sign and to verify. So Zucco's NARCs are like the great cutting edge innovation in encryption. It doesn't have anything to do with a blockchain or a time chain. But the research on Zucco's NARCs or ZKs in general was going pretty slow because it was an academic research. But then Bitcoin came with its time chain. It created a new economy, which is the shitcoin economy. And now people had a huge economic incentive to improve the research in ZK proofs in general, because now they can launch Zcash and make millions. So before the economical incentives to study ZK proofs was very, very low. After Bitcoin, because Bitcoin introduced a new phenomenon, which is the shitcoin phenomenon, you can sponsor and you can monetize research on cryptography much more. So what right now you can have, imagine an insurance company. The insurance company cannot, because of regulatory, it's centralized, completely centralized. Because of regulatory problems, it cannot store your medical records directly, because otherwise the regulator will impose some costs. So what it does is it makes you do client-side some compilation of a form of your medical records. Then it encrypts your records client-side. Then it takes the encrypted blob on server, and on the server, without ever having access to your record, it can interrogate your records with ZK proofs in order to get your premium calculated. So is this cool? Yes. Is this blockchain? Not at all. Not even. I mean, there is nothing even remotely close to the technology behind Bitcoin. Zero. But is this somehow influenced by the story which followed Bitcoin? Yes, because since Bitcoin uses the blockchain or the time chain, and since the time chain is very, very bad at privacy because it's global consensus, then people started to work on ZK snarks, ZK starks, ZK boo, confidential transaction, OWASP, Mimblewimble, confidential assets, and all this stuff is now improved our capability to do zero knowledge proof in general that can be used also in a centralized context. So this is an effect of the time chain. Of course, now you have a client. The client has a centralized insurance company. They want to use zero knowledge proof. What do? You say you tell them they are doing blockchain. I usually I say no, this is not a blockchain. But from now on, I will give up and I will say them yes, this is blockchain. Because everything is blockchain.
We all know that the sequencing of events plus consensus between participants is like a good thing. In many cases. So how should we call that? Call this
control technology. Yeah, it's a concurrency control, basically. It's multi-master concurrency control. It's a field of research that pre-existed Bitcoin. It can bring some inspiration from Bitcoin, but it already existed, and it's very. I think it would be important to communicate the fact that it's very specialistic. So the things you can do with the multi-master concurrency control system are important, but they are not bikes for sure, and not tracking food on the supply chain, not cleaning the oceans, and not changing the world. I mean, you can do multi-master concurrency control.
They can be used for supply chain management.
Sure, but yeah, but the problem for supply chain management, for example, is that imagine an iceberg. You have 100% of supply chain management problems, which are huge regulatory, standard, UX, business logic, and then the part that attains to the multi-master concurrency control is like what? It's 0.003% of the total problem. You can use a centralized timestamping server for 99.9% of the use cases of a supply chain manager. Even if you distribute the signature, you distribute the data, the timing. What are the reasons any supply chain management system cannot use just one server managed by the WWC to do the ordering?
Google Doc.
Or Google Doc. Yeah, but you're using Google spreadsheet, and Google is avoiding double spending.
They're record of every transaction.
They can. They can.
Yeah, but you can keep you can back up a local copy every minute.
But yeah, you can download the copy so you can be tamper evident, and also you are giving a lot of trust. Let's say a complex system like a supply chain management, you are giving trust to so many people that trusting the tampering of the chronology is like the slightest attack surface you can imagine.
Maybe supply chain is best reconciliation between banks.
You will make more money suing Google if they mess with your business by updating that Google Doc than you would from your business.
But
Yeah.
It's like, it's like a different story. You can invent the wheel using like rectangles, but that's not the wheel. Like if we have a reconciliation between like 5 banks, now they use central bank. So instead, in order to avoid using central bank, you can use blockchain, whatever consensus mechanism. Just do it.
Right.
Or they can use Twitter.
You have to repeat the question because we
So-
can't hear
But
from
then
here.
people trust Twitter.
Yeah, but they trust it again. The trust surface for chronology in a normal reconciliation use case is a very small trust surface compared with the more serious trust surfaces like actual collateral, fractional reserve. So you have a giant trust shitstorm and you have chronology.
It's like corresponding account. We have a collateral or relationships.
Yeah, but you can fake the content. So when your problem is that you can fake the content, the attack surface of faking the chronology, I'm not saying it's not a problem. I'm saying that it's a problem that must be contextualized inside the, I mean, when you're doing something like that, you have 99% of super complex shit to put together, and then you have chronology, and you can probably just, your consortium can probably make create an HSM, put the HSM in some basement, and the HSM just does timestamping or proof of publication. I mean, you don't trust the guy. Make 3 of them and make it do 2 or 3.
Yeah, but it's much better, much for to use consensus.
Yeah,
You can do the wheel using rectangles, but that's not exactly can be.
I would contend it's more convenient and simple to use an HSM. What I will agree with you is that this is another effect. I call it the I don't know how to call it, the internet effect. So let's imagine you want to build an internal network for your company in 1995. Do you use the web, like a web portal? No, that's crazy. The web is an open protocol, permissionless, global, very mainframe. And in 1995, the best use case for your internal network is the mainframe because you want control, you want permissionless stuff, you want a walled garden. But if you want to set up an internal network in 2015 or 2025, do you use a mainframe? No, that's crazy. Because since people is already using the open permissionless standard for everything else, then leveraging that infrastructure is way more convenient. So instead of creating an intranet, you create a web portal. So you take an open permissionless network, and on top of that, you create a set of controlled permissioned walled gardens. Why do you do that? Because you are piggybacking routers, user habits, tools, libraries, infrastructures. The same will apply with Bitcoin, in my opinion, after hyper-Bitcoinization. So if we assume that a relevant part of the economy is using Bitcoin for money, then and only then, it makes more sense to use a Bitcoin-ish technology to do everything, not because it's better, but just because everybody else is already using it. So if we assume that everybody is going around with a hardware wallet, then we can use Schnorr signature of Bitcoin as a private key, as a public key system for signatures. It's not the best, but if everybody already has a Schnorr signer in his pocket, we leverage that. But it's not the best solution to use the web application for it. No, I think that the disagreement is you think that it's more simple and more convenient to use a consensus mechanism. I think that we agree to disagree. I think that it would be more convenient and simple and fast and fire up a server, Linux server, in a room to do the timestamping, and that's all. I think that would be more convenient, and I think that the difference in trust model would be there, but super small. But I think that in my example, after hyper-Bitcoinization, you can there is more sense into reusing Bitcoin technology. I can give you another example. Now,
Yeah, no, it's a tough argument because, like, I argue from an economic perspective. You guys are arguing from an efficiency perspective. From an economic perspective, I always argue it's ridiculous for you to make up your own currency to sell your product, whether it's Ethereum smart contracts or, you know, use my token to buy from my copy of eBay. It's the same economic argument. Why are people going to use your currency when you have a common currency?
precisely. When you have a standard, the convenient things to do is to use the standard. But the problem with standards is that many people right now, they're coming out, they're saying, hey guys, I have a standard, please use it. It doesn't work that way. First, the standard is established, and then it makes sense to use it. Before, it's like when you have a Hyperledger, like we need a standard for blockchain. Everybody introduced their own standard, and now we have a collection of 50 standards. I mean, we don't have a standard. We have a collection of useless things that nobody will use.
Hey, Giacomo, before you take the next question, I'm going to do a screen share real quick. So this is the first place where the word blockchain appeared. It was in the code, not in the white paper.
Yeah, and it was like
That's on the board. as well.
blockchain separated in the code. I think that there is so blockchain altogether is never used by Satoshi. Blockchain separated once. Chain of blocks is used probably 4 or 5 times. And time chain altogether is used probably 20 or something. There is as I showed yesterday, there is a tool on GitHub that analyzes all the stuff written by Satoshi in Bitcoin Talk, white paper, code comments, and it counts everything you want to count. So in order to know that, oh, Ton was reminding me yesterday that I didn't credit that the first time that the time chain thing came out was actually during a Bitcoin Uncensored
yeah, it was
episode.
a Bitcoin Uncensored podcast, probably 2015, Johnson and DeRose.
So due credit to Janset and DeRose, I mean the old DeRose, and yeah.
Hey, Giacomo, thank you for your explanational skills and storytelling. I just want to ask about in the sense of scaling of Bitcoin. If we don't want to involve some federation stuff or some sort of practice, let's say, and we think about it like a set of trade-offs. Do I understand right that time blocks and multi-sigs is all that we can use to make some constructions or for some scalability?
We got to repeat the question.
Yeah, the question is, in the context of scalability of Bitcoin, when we want to use stuff like sidechain and all of that in order to scale Bitcoin, is time locks and multi-sig the only 2 primitives that we can use to build everything? So first of all, a quick comment about the premise of your question. Sidechains, I don't think they are mostly for scalability. Sidechains are not really for scalability. So also, what does it mean scaling? Off-chain is for scalability, but sidechains are mostly for experimentation without reinventing money. So it's a little bit different. There's some overlap. But the thing is that, again, let's try to separate always Bitcoin with small b, Bitcoin as an asset, from Bitcoin with big B, which is Bitcoin as a network. Maybe when Satoshi will be $1 worth of purchasing power, we will stop using the term Bitcoin. We will use the term Satoshi, and we will have Bitcoin, the network with big B, and the Sats, the staking Sats as the name for the asset. That will be better, because if we mix the 2 meaning of the word Bitcoin, you don't understand that Bitcoin as an asset can scale pretty good in many ways. Trustless ways, like Litecoin, Lightning Network. This is a bad lapsus. Like Lightning Network, or in trusted way like Sapo or exchanges. So there is a degree of trustlessness of asset scalability. The asset Bitcoin can scale. It is the system Bitcoin intended as the blockchain that cannot scale and cannot scale very much. So the system Bitcoin has a lot of problems of scalability. The asset Bitcoin has 0 problems with scalability. You just use, I mean, how do you scale gold? With paper gold. So paper gold is, when Satoshi proposed Bitcoin, Hal Finney, like the first or the second answer from Hal Finney was, This is great, but unfortunately, this is a global consensus state. It cannot global consensus system. It cannot scale. Even if you force it, eventually it will meet a scaling ceiling. And Satoshi was disagreeing back then, and I think he was wrong, and Alfini was right. And Alfini said, but it doesn't matter because the asset will be moved on the system at base layer, and then people will just use credits denominated in Bitcoin with little small banks. Which, I mean, what is the difference with the gold standard, which already failed? The difference is that settling your credit in gold is super expensive. So Germany is still waiting for the gold in Fort Knox since probably what is 50 years, while settling on chain an exchange promise, even if somebody's still waiting for empty gox withdrawal. Yes, but it's you can get. I mean, you know that something is wrong way before than with gold. So the settlement cost, even if they are huge, they are not anyway comparable to physical gold. So Alfini said, the only way to scale Bitcoin, the asset, will be to use Bitcoin, the system at base layer, and to use trusted fiduciaries at top layers. The cool thing with Lightning Network is that we can actually scale Bitcoin, the asset, even in a trustless way with stuff like Lightning Network. Now, back to your question. How do we build these trustless second layers, which can be Lightning, like stuff, state chain, side chain?
Very carefully, and it takes a while.
Yeah, yeah. And in a way, what you said is true. We have only few primitives that are multi-sig, lock times, check sequence verify and check log time verify, and so extrospections about time, and well, and also you have the pre-image revelation, like HTLC in Lightning doesn't use the HTLC use a pre-image contract, which is another primitive. Basically, use these three primitives and you build everything you want. Everything will make sense. It may be possible to use something else. For example, there is a proposal to use some kind of elliptic curve math inside the Bitcoin script, directly, some kind of multiplication or sum inside the Bitcoin script. It may make some sense. It may make, for example, routing Lightning better without sharing the secret. So you can do some cool stuff if you add some kind of elliptic curve math in the system. But basically, you don't need Turing completeness or rich statefulness. You don't want that. The typical argument about that is that if you're creating a failure critical system, like the mechanical arm moving the plutonium inside of atomic power plant, then you don't want the mechanical arm to be able to do a lot of very cool stuff. You don't want that to do a very, very small number, thank you, of very predictable stuff, which is basically plutonium down, plutonium up, and if the power goes up, plutonium up. That's all the things you want to do. And you want to build complex electricity policies with these very simple primitives. The same goes for airplanes. It's not cool when you have a software, avionics software for an airplane, and your avionics software can just do a few things: flap down, flap ups, engine on, engine off. Wheels down, wheels up. And then I come to you, and I'm a block.
And be careful who builds it.
Exactly. And already they can fuck up pretty hard. Now I arrive, I'm a blockchain consultant, and I tell you, this system you're using for your plane is not even Turing complete. You cannot even loop the amount of flap up or flap down. I can give you a system which is better because now you can directly in JavaScript code the dynamics of your airplane. Now you have the powerful expressivity of JavaScript for your avionics system. No.
Oh, hey, before you get to the next question, it's I don't know if you ever seen this cartoon from XKCD.
Yeah, this is very good.
For standards.
This is great for Hyperledger. So how standard proliferates? Situation: there are 14 standards there are 4 competing standards. 14 ridiculous. We need to develop one universal standard that covers everyone use cases. Yeah, soon. Situation: there are 15 competing standards. The new one and the legacy ones that didn't disappear. So yeah, this is a very good representation.
Here are some examples like charging and AC chargers, is the messengers, cryptocurrencies.
Hyperledger. Yes.
What do you think about
about quantum resistance algorithm, is a challenge for Bitcoin. And the next question, what are your forecasts regarding the future of distributed growth? Is there something different blockchains, something custom consensus model in single role, or we must move to building something like OSI model in www. What do you think about this?
So I will not answer in a very deep extent to the first question, which is about quantum computing, because I'm going to give a full speech in Bratislava next week, basically on the 16th, I think. I will be in Parallel Napoli in Bratislava about a talk. We didn't talk about Bitcoin and quantum computing. I do think, I mean, I was a theoretical physicist before Bitcoin. Quantum mechanics is cool, but it tends to be, I mean, when there is a lot of information asymmetry in something, there is people who don't know anything about that, and there is a strong incentive to create bullshit, a lot of bullshit, because people cannot check it out, they cannot verify. And quantum computing is a field in which there is some bullshitting around. Sure, you can create some qubits. They are not as many as you think because you have error cancellation. Creating them at room temperature is hard. So long story short, the kind of error corrected qubits you need for Shor algorithm in order to solve the factorization problem is probably something that I will bet we will not have for the next century. But I'm super pessimistic. Some people say it's 30 years. The thing is that if we have it, then we have to update the ACDSA somehow. The problem is that the quantum resistant cryptography is so new. I mean, when Satoshi wanted to create Bitcoin, there was a Schnorr signature without a patent since 1 year. But he didn't choose that. He chose the OpenSSL with the CDSA for the simple reason that everybody was experimenting with that since basically, I don't know, what, 30 years. So it was already tested, established, known. Quantum, post-quantum cryptography is still new, and there are many cases of quantum resistant function that were discovered to be classical non-secure. So you can, it resists quantum computing, but it doesn't resist brute forcing. So it's a mess. It's something that can be done, but we cannot put, I think we cannot put into Bitcoin now anything which is so new that we don't ever know where it's going to stop. It's like putting, so Zcash launches with Zk snarks, but then some Israeli people found Zk stars, which are better. Then Microsoft discovers a new kind of Zk snarks without a trusted setup. So it's so ongoing that you cannot set for a standard. Satoshi used an established standard, which was ACDSA. Now, after many years, we can maybe move to Schnorr. So I don't think you can rush post-quantum cryptography inside Bitcoin soon. Of course, if all the people with some experience in quantum computing I know, they are skeptical about short-term Shor algorithm solving quantum computers, because it's crazy the amount of stuff you have to do to maintain entanglement between thousands and thousands of qubits with error correction. So probably it's just science fiction. If it's not, anyway, I think we cannot put that new stuff that we don't even know, we never tried, we don't know if they are classically secure inside Bitcoin. So let's hope that that experts in quantum computing are mostly right, and that the quantum FUD is mostly wrong. What I'm afraid of is that quantum computing will be the new shitcoin mantra for a while. So now it's not proof of stake, now it's not Turing completeness, now it's not, I don't know, big blocks, gigamex, now it is quantum computing. So yeah, I'm a Bitcoin maximalist, but what about this scam coin with quantum resistance? Yes, so it will probably be a shitcoin mantra for a while. Oh, sorry, the second question. The Aussie layers. I think that layerization is the way. And I think that the Aussie is a bad example, because if you think about that, Aussie was an ex-post rationalization of a layerization that, or a standardization that was naturally. So the market kind of finds a natural standardization of things, and then the bureaucrats arrive and they try to superimpose ex post a rationalization on something that already happened. So ISO-OSI model was, was just a rationalization ex post of the TCP/IP stack, of the Internet Protocol Suite stack. I think something similar will happen. Bitcoin will evolve, Lightning Network will evolve, state chains and side chains will evolve, hardware modules will evolve, and when we will have some kind of standard ecosystem, some bureaucrats will try to create an official standard for that, and it will be as useless as any other official standard, in my opinion.
So still related to the quantum computing question, I assuming it's like real threat is not just science fiction, or like a general question for most security threat. Okay, imagine that we actually have quantum computer like in 100 years or whatever. Do you think that we will reach a point where Bitcoin is so decentralized and so hard to change that even if we have a serious security threat, it may be possible to change Bitcoin to fix this vulnerability while staying in consensus? So you think that like even in 500 years we will still be able to fix this kind of stuff?
So I think that so the question is, let's assume that quantum threat is real and not FUD, as I suspect it is mostly. But let's assume there is a generic life-threatening risk on Bitcoin. But we also know that Bitcoin is getting harder and harder to change, and that's a good thing, because we want stability, reliability, predictability, and we don't want a lot of change, because a lot of change, it is an attack vector for regulators, it is an attack vector for governments. So if you have a team maintaining a protocol, then the protocol can change in a non-compatible ways, and that's bad for security, censorship resistance, and reliability. TCP/IP doesn't change basically since version 4. So Bitcoin is getting harder and slower to change, and that's good. But what if this threat is real and we have to change very fast? I don't think that's much of a problem for this simple reason. This is a potential life-threatening threat, life-threatening risk. So that means that if Bitcoin doesn't change, it dies. So the coordination problems will become super hard to solve in non-life-threatening situation, but they will still be very easy to solve in life-threatening situation, because you have a small group that find coordination among a post-quantum signature. Then the rest of Bitcoin becomes unused. You can do a hard fork, soft fork, whatever you want. The rest of Bitcoin just collapses because it's unusable. So basically the consensus is so, the game theory there is super easy to figure out, in my opinion.
What if we have two proposals?
Okay, we have to kill one of them. No, that would suck. If we have two equally, but that's a very strange race condition. You need, because maybe the best proposal is the second. In that case, I think the first one will have more traction. So usually you have very fast, you have a collapse of social consensus, which is pretty fast in emergency. So usually when you have an emergency with two proposals, either you have a government where you have a formal bureaucracy and then you can have infinite discussion, but in real world, when there is a fire and we have to decide if try to put it out or run away, social consensus will probably precipitate pretty fast. So I'm not personally losing my sleep on quantum stuff.
Found it.
Oh, so yeah, this is the new one, right?
No, it's the old one. But
Okay,
a
the
cool
old one.
picture.
Yeah, very toxic. So I'm not role playing here. We made a conference which is called Understanding. I mean, I love D&D and everything, but this is because the conference was in Malta. Inside, we did the dinner, speakers dinner inside a kind of a medieval citadel. So all the speakers of the conference were edited by the great graphic artist of Tone, Peter, in this way. If you go to Understanding Bitcoin, Understanding BTC,
understandingbtc.com or Understanding Bitcoin YouTube channel to watch.
Okay, you can find also the other speakers. The graphic artist took any speaker, putting some kind of medieval graphic related to the nationality of the speaker. So it's pretty cool. It's very funny. So if you want a cool Middle Ages image of you, you should come as a teacher to the next Understanding Bitcoin. We will need teachers in order to, the purpose of this conference is to teach non-developers, but hardcore Bitcoiners, how to do basic stuff like installing Electrum personal server, using Wasabi, using some hardware wallet, installing Bitcoin Core, verify the signature on Bitcoin Core and stuff like that. I would say simple stuff, but for many people, even just using command line is not simple. So we need a lot of help and a lot of patience and a lot of teachers. Okay.
Yeah, we have other pictures. We have other pictures of Giacomo.
Okay, now this I didn't authorize this. I mean, also I think this could be some kind of joke about my height. So Saifedian and me and Jimmy, nice. Why Nova gets to be Jan Solo? I mean,
that's Rodolfo. All right, guys, any more questions?
Thomas, do you want to say something about, since you're here, something about the new, you want to rise the hype about Lightning?
I haven't prepared anything.
If you want, since we have a great.
Oh, wait, you're mic'd up. Wait. You mind coming over? We're still live streaming, and gonna clip that on. So you're also no, you still need that, but you're limited on.
All right, so this goes to
That's
the.
it.
Whoops.
You're limited on your distance of walking around.
I'm on the leash.
Yes.
Okay, so how much time do I have?
I'm
Other
not,
6 hours.
yeah. I don't know. I'm not responsible for keeping the
How
clock.
much time can we have it still, or how late is it? Not in rush.
There's no.
Okay, so I'm going to give.
It was important to say that after Giacomo went into the audience.
Yeah, just a few words, 2-3 hours, no more. I don't know. I haven't prepared anything. I'm going to improvise. So.
Let's do a small break after you talk, and then we'll continue.
Oh.
Yeah, sure.
Okay.
Yeah, okay.
Yeah, take 5 minutes.
This is just
a little bit over. A little bit
I'm
over.
on the
A little
leash.
bit.
Yeah?
Perfect. Yeah, right there.
Okay.
Exactly.
I
Excellent.
must stay in that
Perfect.
square.
Yes, right there.
Okay.
Excellent.
So I'm Thomas Verklin. I'm the main developer and also the founder of the Electrum wallet. Maybe you can put the website electrum.org. That's as much as I have for slides for today. What's that?
That's not it.
ADO Electrum. Yeah.
Is it a phishing website?
Yes.
Electrum.org.
Electrum.
Yeah,
.org.
.org.
There you go.
Okay.
Got it.
So Electrum is one of the oldest Bitcoin wallets. I started this project in 2011 after the mybitcoin.com fiasco. So at this time, it's very old, but mybitcoin.com was probably the most popular wallet after Bitcoin Core because it was so easy to use. It was a website, it was custodian, so it had your Bitcoins, and it was run by Anonymous. So that's very interesting.
What could go wrong?
It was 2011, so yeah. What could go wrong? I mean, it was so useful because it was a lot easier to use, and ease of use drives a lot of users. So one day, mybitcoin.com closed, or the owner said that he had been hacked, and of course this guy was anonymous. And the interesting thing here is that this guy said, so the hacker did not steal all the coins. He stole only, I don't remember, it was either 49% or 51, something like that. And so he said, yeah, okay, you know what? I'm going to reopen the website in a few months or in a few weeks so that you guys can withdraw your balance, but you will have a haircut. You will only get 50% of your deposit. And this created a huge mess on the blockchain because you can imagine that the day the website was reopened, everybody wanted to withdraw their coins. So whoever stole the other half had the perfect cover to do that. So this is, yeah, So this is also a good reason to think that the actual guy who created the website was the thief. So at this time, I was not a user of mybitcoin.com, but this really affected the price of Bitcoin. And I had already the ingredients to create a wallet because I had created a few scripts. I just merged a block explorer with a few Python scripts, and this was my own personal wallet. I was not trusting my own wallet very much at that time because, I mean, it was new, it was untested. After some times, I decided to release it. And so this was the first, this was a few months after mybitcoin.com. It was Electrum, the first version. The first version of Electrum was not even SPV. It had the security of maybe something like blockchain.info, but without the risk that the website actually gets hacked and steals your coins, because that's what can happen with a website that runs on JavaScript. So then over the years, Electrum got improved. It got SPV, it got multi-sig, it got cold storage, it got support for hardware wallet, all this kind of stuff. And what I announced recently is that we are soon going to have support for Lightning. So this is a huge project. We have started to develop this about a year ago on a separate branch on the GitHub repo. And it is not yet ready for general use. It's still full of bugs, and we are still working on that. But it has reached a state where we are going to merge this in the master branch of GitHub. So that means that more people are going to be exposed to this code, and they will be able to test it, and we will get more feedback. So this is it's a very important step in the iteration process when you move something from a branch to your master branch. Everybody is familiar. Who has used a Lightning client here? Who has used Eclair? Who has used something else than Eclair? Okay, so most of people here have used Eclair. So Electrum is going to work very similarly to Eclair. Eclair is actually using the Electrum servers, the Electrum infrastructure. So in that sense, we are going to be very similar. For the on-chain interaction, we use the Electrum servers, but for the interaction with the Lightning Network, we have implemented the whole Lightning protocol. So we have implemented well, not everything, because we are not doing forwarding and this kind of stuff, but we have implemented a full Lightning node. Yeah, so I don't have an ETA for that, but yeah, that's it. I don't know, do you want me to answer specific questions? I mean, I haven't prepared anything else, so yeah.
Let's do like a 10 minutes break.
Okay.
When
Thank you.
All right, guys, so we're on a 10-minute break. I'm still live streaming, and I have 10 minutes to pull up some TA. Let's switch to screen share. I'll be projecting it to the audience, but I won't be talking too loud. Let me open this up here. Let's see what's going on. I have not looked in charts in probably a day and a half. So this is my first look at charts in a while. So I'm gonna just extend this box that I had before. I want it to go just so we can see the setup trend line. And my rules are the same, right? Like if we can break this rectangle, can you guys see this? Oh wait, you can't see this. My bad. Boom. Now you should be able to see it. There you go. Maybe you could see it. In any case. So if the price of Bitcoin, if it gets into this box, I'm as close to bullish as I can be without announcing it on Twitter. If it can get over this box, I have no choice but to become a bull. But until it does that, I have to be skeptical that this whole thing is just a bear market rally or a dead cat bounce, even though it was big. What people still have, oh, this is a 4-hour chart. Let me go to a higher level chart. What people have a problem, maybe the daily chart's better. What most people have a problem comprehending is that it really, like to me, it's completely irrelevant how high the price of Bitcoin got. People are like, oh, well, you didn't buy at 3,000, which I actually did. I bought at 4,000. I just sold at 5. But when people say, oh, we're at 13,000, that means it's a bull market. No, it actually doesn't. That's not the definition of a bull market. I mean, I know a lot of you think that crypto is different, and that's fine. If you want to change the rules for Bitcoin, that's fine. I don't. I respect speculative asset trading at a higher level than Bitcoin. Could be wrong, but that's my respect. So the only way, like without any significant pullbacks, the only way we can claim that it's a bull market is if it went to new all-time high, which it didn't do yet. And the other way to claim it's a bull market is after you see a significant pullback, which for Bitcoin, to me, is a bare minimum of 30%. And that's exactly what we got about a week or two ago, right? So at this point, I'm willing to admit that we're in a bull market, but we still need to go higher than the latest swing high, or at least close enough to it. So that's my view on the situation. Until it does, until Bitcoin clearly makes a new swing high above this area here at 12 and a half-ish, ideally all the way beyond 13,000. I will have to assume that we are now in a side downtrend from the current uptrend, and this side downtrend could take us significantly lower. And we will see what happens. We still have not even pulled back to the 50-period moving average since the golden cross between the 50 and the 128-day. Sooner or later, we're going to do that, okay? So that's kind of my view on it. And for now, we are in a no trade zone, as my last tweet pointed out. Even though I didn't look at any charts, I kind of generally kept an eye on the price. So as long as we stay above this area here, right? So if we go below these lows, I am pretty bearish. If we go if we go above these highs that are in the box, I'm bullish. Until that happens, we're in a no trade zone. Now, because we established a lower swing high right here, just under 12,000, we can almost say that I can almost take this box and move it to here like that. And now I would lower the top side of the box to be just above the setup trend line. And I can now say, hey, if we get over this box, which is a combination of the latest swing high and setup trend, that's enough for tone base to be bullish, okay? Because now we established a lower high, and we also established a higher low. So guess what this looks like? This is a de facto symmetric triangle, okay? I don't want to draw too much crap on this chart, but this is a de facto. I should make it like maybe yellow or something because it's neutral. So I can do this, and then I can do this, right? So this is almost a, I go here, I go here, and then it's not gonna look pretty. It's not gonna be great. It's not gonna be perfect. You have to fudge it a little bit, but you know, maybe I'll go into here. Oh, maybe not. Maybe I'll go into there, and It's not a great symmetric triangle, but it has the spirit of the symmetric triangle in that, oh, my battery's about to die. Well, you guys got about 5 minutes at most. So it's a de facto symmetric triangle, which can really break one way or another. So we'll keep an eye on that as well. I think Ethereum is on the verge of a complete and utter breakdown to something very, very ugly. Yep, and I think we're done. I'm going to glance at S&P. S&P is hanging in at the all-time high. And that is it, because my computer is dying. I'm going to stop screen share, and we're going to end this session.